So this is your last factoring video over special cases. So I'm going to teach you some tricks to use for some special types, but remember you can always fall back on your splitting the middle when A is not 1. Okay? So GCF, again, always check the first time you factor. Make sure that you are looking for that GCF. It's going to make life so much easier. So our first type of special case is known as difference of two squares. You must know this. You'll see these quite a bit. So difference meaning subtraction. Two squares meaning perfect squares. So it has to be subtraction and it has to be two perfect squares. So basically what happens is if we have that, we can set up two sets of parentheses, one with plus, one with minus, and then we can basically do the square root, figure out what is being squared. So if we were to prove this, show you it written all the way out, if we were to FOIL it, we'd get a positive AB, and we do our inner and outer, and then we get a negative AB, which together cancel each other out, which is why there's no middle term with these, and we only have two terms. And here's an example with numbers. So if it's 16x squared and negative 9 minus 9, so again difference, then 16 is really 4x that's being squared. 9 is really 3 that's being squared. So we would have one that's a 4x plus 3, one that's a 4x minus 3. And here's our proof here of refoiling it out and how we would have our negative 12x, positive 12x in our middle that would cancel out, which is why we have no middle term, because it truly cancels. So there is going to be a trick question on your mastery quizzes and on things that you will see to make sure that you truly understand and you are looking for difference of two squares. So this one down here, this is not difference, is it? Because we have addition. We see two perfect squares and automatically most of the time we think, oh, I can factor it. But no, because this is addition, there are not two numbers that multiply to get 49 that would add to get a 0 for the x squared. So let's just kind of look at it like if we truly had a middle term in there. What would be the factors of 49 that could add to get nothing? Well, it would have to be 7 and 7, but one of them would have to be negative. But that's not going to multiply to get us a positive. That's why this is not possible. You can't factor. Can't factor when it is a sum of squares. So let's go ahead and take a look at some examples together. You can use the trick, or again, you can fall back, and I'm going to show you how to do it with the long method, just in case you forget how to do this difference of squares. Real quick, if you can remember the rule, let's take a look. What is being squared? Well, just x. And what is being squared for 49? 7. So we're going to take our a and our b, and we're going to put them together. And remember, one is going to be a plus, it doesn't matter which one, and one is going to be a minus. And that's it. Make sure that you're looking for what is being squared. Let's try another one with that method. What's being squared here? Well, a 3x, if I squared that, would give me 9x squared. And what is being squared here to get 4? Yep, you guessed it, 2. So this is my first term, this is my second term, and that's going to be the case for both sets of parentheses. So I want a 3x and a 2, and a 3x and a 2. Remember, one's plus, one's minus, it doesn't matter which one, but make sure that they are different. All right, let's take a look. What if we forget how to do it? What if I can't remember that trick? Well, you can always fall back on first times last. So this one is basically 16x squared plus, remember we don't have any middle term, so 0x is really in the middle, no x's. We don't write that because we don't normally write a 0x, but I'm doing that to show you. So we have first times last, So what are the factors of negative 16 that would add to get 0? Well, that would have to be 4, and one of them would be negative. So together, 4 minus 4 would give you the 0. So let's go ahead and either box method or group it. Plus 4x minus 4x, and then minus 1. So again, we're keeping the first term, keeping the last term, replacing or splitting the middle, which our middle 0, with the two factors. So we group, and we get 4x that we can take out there. We get a negative 1 we can take out there. And we have what's left, 4x plus 1. And we have a 4x plus 1. So we have 4x plus 1. And we have a 4x minus 1. Oh, does that fit our pattern? Oh, yeah. The 16x squared is really 4x squared. And then 1 is 1 squared. And there's our factors there. One's a plus, one's a minus. So see, you can fall back on this method if you forget at any point. Try these last 3 on your own and check when you're ready. Now, I hope you didn't let 5 and 6 trip you up. This one's pretty straightforward, just like the ones up above, but remember, 5 and 6, we're always starting, no matter what, with any of these questions with GCF. And yes, there is a GCF even with difference of squares, so we need to take that 4 out. So if you got the answer of just splitting it up of 4x minus 9 and 4x plus 9, your answer is technically not correct because there's still a GCF in there. So we want to take that 4 out and then do difference of squares or do the long method, whatever you want to do. But this should be your final answer here with your GCF out front. Same thing with number 6. Pull that 25 out, then do difference of squares for your final answer. All right. So again, if you were struggling with these, you could split that middle factor. I showed it to you up above already. And I could show it again really fast if you still need to see another example of. So 9x squared minus 0x minus 4, factors of negative 36 that would add to get 0, 6 and 6, one of them negative. So 9x squared minus 6x plus 6x minus 4, group, pull out a 3x, pull out a 2, and we wind up with 3x minus 2 and 3x minus 2. So we have a 3x plus 2 for our GCFs and a 3x minus 2 for our matching parentheses, and there's your answer. So you could split that middle term even if you forget. Try some challenging questions. See if you can do it. If you're trying maybe that difference of squares method. Again, think about what's being squared. Check your answers when you're ready. And those answers are here. Again, 1 plus, 1 minus. Don't forget that. All right, let's take a look at our last type of special case, which is going to be what's called the perfect square binomial. So again, if you still don't recognize this, which you probably might not recognize these because they look like a lot of the other ones that we're going to do, you can, again, always fall back on the box method or the grouping method. Okay? So these are just some examples to show you these perfect squares. So basically, it's when you have a perfect square at the beginning and a perfect square at the end, and when we factor it out, we wind up with the same binomial just being multiplied by itself. Sometimes it's a plus, sometimes it's a minus. Okay, so basically I'll show you what it looks like for this one, and then I will give you another example, and then I'll have you try some, and then I'll do this one, the long method up here. So here we go. What's being squared at the beginning? Well, that would be a 2x squared. What's being squared at the end? A 1. And to double check the middle, basically we take 2x times 1, and we double it. So 2x times 1 is 2x, times 2, yep, that's 4x. So we know this one is a perfect square binomial. So basically, we always take the sign that's at the beginning, and that's the one that's going to go between our factors here. So we're going to have our set of parentheses that are going to be squared, and we're going to put our first term first and our last term last, and we're going to keep that sign. Pretty short and sweet, but again, you have to recognize that these are perfect square ones. So let's do this one a short method, and then I'm going to do it the long method, and we'll see if our answers match. So short method again, perfect square at the beginning, perfect square at the end with 3 terms here. So it's a 4x that's being squared at the beginning, it's a 3 that's being squared at the end, and 4x times 3 is 12x, double it, yep, it can get us 24. What sign do we need? Negative. Again, we always take this sign that's at the beginning. So when we put our parentheses with it squared, again, we're taking it times itself, we want our first term first, 4x, we want our last term last, 3, and we want our sign, that's the first sign. So let's see if we get that same answer doing it the long method. So we want to take first times last, because there's no perfect square that I could divide. Actually, there is, isn't there? Well, no, because 16, I'm thinking that's 18. Nope, no perfect square, we can't take a 3 out. So 16 times 9, 16 times times positive 9 is 144. So we're going to come up with the factors of 144 that add to get negative 24. We could use our calculator, but I know 12 and 12 together get me 144, and if I make them both negative, that would get me negative 24. So let's replace the middle, and you could either do box or grouping. And I'm going to go ahead and group because I don't really have enough room to box. So the first 2, I can take out a 4x. The second 2, I can take out a negative 3. And then when I pull those out, I've got a 4x minus 3 and a 4x minus 3. So the first part of my answer, I've got a 4x minus 3 that's repeating. And then I also, my group, my GCFs are 4x minus 3. Well, that's the same thing, isn't it, as 4x minus 3 squared? And that's what I got down here. So see, you can do that long method if you forget the shortcuts for either of these perfect squares or difference of squares. So try these last 2 on your own. Check when you're ready. And those last 2 should be 5x minus 4 squared and x plus 5 squared. Make sure to write any questions that you have. And there is this back page in case you need some extra examples for all different types of methods as you prepare for your factoring mastery quizzes.